Now they have to prove that these aren't extraterrestrial. And they also move without creating an exhaust or breaking the
asteroid could hit Earth within the next decade. It could be big enough to destroy a city.
Now they have to prove that these aren't extraterrestrial. And they also move without creating an exhaust or breaking the sound barrier. They didn't specify what other was, but you can fill in the dots yourself.
Expelled, and it has been traveling through interstellar space for hundreds of millions of years, billions of years, we don't know.
A mysterious object from another star system just flew through our solar system and left behind more questions than answers. Now in 2025, powerful new analysis techniques have revealed interesting new data about this visitor. Now Michio Kaku warns us the truth about Oumuamua might be far more disturbing than anyone expected. In 2017, astronomers detected something unprecedented, a cigar-shaped object speeding through our solar system on a hyperbolic trajectory. They named it Oumuamua, Hawaiian for a messenger from afar arriving first. But what made scientists truly uncomfortable wasn't just its bizarre appearance. It showed no ice, no heat signature, and no comet tail, even as it passed near our sun. And then, inexplicably, it sped up without any visible fuel or propulsion system. Theoretical physicist Michio Kaku and a growing number of leading scientists are examining this fresh evidence and reaching a startling conclusion. What we witnessed might not have been a natural object at all, but something far more unsettling, advanced technology from beyond our solar system, too precise to be natural. What truly shocked astronomers wasn't just that Oumuamua entered our solar system, it was what happened next. As it passed by the sun, it accelerated, not in a random, chaotic way, but with a precise, controlled trajectory that defied explanation. When astronomers first saw the acceleration, they thought it must be outgassing, like a comet ejecting material. But there was absolutely no visible ejection of mass, nothing, not even a wisp of vapor. Michio Kaku and his research team found groundbreaking new data after re-examining Oumuamua's trajectory using quantum-enhanced optical modeling. This wasn't just a refinement of old observations, it was an entirely new analysis method.
Oumuamua is less than a millimeter thin, but very wide like a sail, harnessing solar radiation to propel itself.
That revealed something astonishing. The new data specifically shows that Oumuamua's acceleration wasn't random at all. It followed a mathematical pattern that precisely counterbalanced its tumbling rotation. For every 7.3-hour rotation cycle, the acceleration vector adjusted by exactly the right amount to maintain its course. Natural objects don't self-correct their trajectories. Comets don't compensate for rotation. Asteroids don't make micro-adjustments to stay on course. The quantum optical analysis revealed something else that had been missed. Microscopic variations in the acceleration that correspond exactly to the object's changing orientation relative to the sun.
Oumuamua is so weird. Let's study objects like it in more detail so we can figure it out.
These variations create a pattern that matches theoretical models for advanced light sail technology, the kind that can maintain stability regardless of orientation. Kaku's team found that these micro-adjustments would require what he calls responsive surface geometry, essentially a surface that can adapt its reflective properties dynamically. This is technology.
This is the very first object that we'd ever discovered that had originated outside the solar system.
We've only begun to imagine in theoretical papers, not something that occurs naturally in space. The precision needed to achieve such trajectory stability while tumbling is beyond our current engineering capabilities. It's as if Oumuamua knew exactly how to interact with solar radiation to maintain its course. This raises a provocative question.
And in fact, it's not just rotating, it's tumbling. So it's not just it's going end over end, but twisting as it does so.
Oumuamua would be equipped with an advanced passive sail system designed to harness radiation pressure from stars, a silent, efficient propulsion technology that allows it to drift purposefully through interstellar space. If you're finding this as mind-blowing as we did, make sure to hit subscribe and the notification bell. We'll be bringing you more revelations about Oumuamua and other cosmic mysteries that
we don't see that in our solar system. None of the asteroids in our solar system look like that.
Mainstream science isn't talking about. A dead zone launch. But what happens next is even crazier than the propulsion anomalies. The origin of Oumuamua raises even more troubling questions. Using the European Space Agency's Gaia spacecraft data, astronomers have now precisely traced Oumuamua's trajectory back to its origin point. The Gaia
It was pushed away from the Sun by some mysterious force.
mission has mapped over 1.8 billion stars with unprecedented precision, creating the most detailed three-dimensional map of our galaxy ever assembled. When scientists ran Oumuamua's trajectory backward through this stellar database, they made a discovery that defies conventional astrophysics. The object came from what astronomers call the local standard of rest.
There was no fuzziness around it that you would expect from a comet as the ice was turned into a gas.
But specifically from a particular region within it that's eerily devoid of the cosmic mechanisms needed to naturally eject objects at interstellar speeds. Here's why this is significant. Natural interstellar objects should originate from regions with strong gravitational dynamics. Binary star systems, where two stars orbit each other, can eject comets and asteroids through complex gravitation.
How cool is it that something came out from some other origin, passed through our neighborhood, and it possessed some form of organics?
Interactions. Massive stars can blast material outward through powerful stellar winds or supernova explosions. But Oumuamua's origin point has none of these ejection mechanisms. The new analysis confirms there are no binary star systems within 10 light-years of its origin point, no massive stars that could generate the necessary ejection velocity, no recent
Then something weird happened. As it was moving away from the Sun, it was slowing down as you'd expect. But it wasn't slowing down fast enough.
supernova events in that region, no star clusters with the gravitational dynamics needed to accelerate an object to interstellar speeds. This region is essentially a gravitational dead zone, a quiet neighborhood of space where objects should remain relatively undisturbed. There's simply no known natural mechanism that could have accelerated Oumuamua to the velocity needed to escape its home system and travel.
A laser highway that could be right next to the Earth for all we know, carrying the digitized souls
to ours. The ESA data is clear. This object came from the one place in our stellar neighborhood where it shouldn't have been able to leave on its own. It's as if Oumuamua was placed in this quiet region. A mysterious object from another star system just flew through our solar system and left behind more questions than answers. Now in 2025, powerful new analysis.
It was really mysterious, and so everybody who was observing it thought it was an asteroid.
These techniques have revealed interesting new data about this visitor. Now Michio Kaku warns us the truth about Oumuamua might be far more disturbing than anyone expected. In 2017, astronomers detected something unprecedented, a cigar-shaped object speeding through our solar system on a hyperbolic trajectory. They named it Oumuamua, Hawaiian 4. A messenger from afar arriving first.
Force that is pushing it, and it's not clear what this push is from.
But what made scientists truly uncomfortable wasn't just its bizarre appearance. It showed no ice, no heat signature, and no comet tail even as it passed near our sun, and then inexplicably it sped up without any visible fuel or propulsion system. Theoretical physicist Michio Kaku and a growing number of leading scientists are examining this fresh evidence.
Surface of a spaceship that was ripped apart, and you just see the surface being pushed by reflecting sunlight.
And reaching a startling conclusion. What we witnessed might not have been a natural object at all, but something far more unsettling. Advanced technology from beyond our solar system, too precise to be natural. What truly shocked astronomers wasn't just that Oumuamua entered our solar system. It was what happened next. As it passed by the sun, it accelerated not in a random chaotic
like a little jet engine on the surface. Just gives it a little thrust over time.
way, but with a precise controlled trajectory that defied explanation. When astronomers first saw the acceleration, they thought it must be outgassing like a comet ejecting material. But there was absolutely no visible ejection of mass, nothing, not even a wisp of vapor. Michio Kaku and his research team found groundbreaking new data after re-examining Oumuamua's trajectory using
If Oumuamua had a metallic surface, it would reflect light very well.
Quantum-enhanced optical modeling. This wasn't just a refinement of old observations, it was an entirely new analysis method that revealed something astonishing. The new data specifically shows that Oumuamua's acceleration wasn't random at all. It followed a mathematical pattern that precisely counterbalanced its tumbling rotation. for every 7.3-hour rotation.
I was disappointed. I would have been much more excited if we have found evidence for an alien civilization.
Cycle, the acceleration vector adjusted by exactly the right amount to maintain its course. Natural objects don't self-correct their trajectories. Comets don't compensate for rotation. Asteroids don't make micro-adjustments to stay on course. The quantum optical analysis revealed something else that had been missed. Microscopic variations in the acceleration that correspond.
When Oumuamua was discovered last October, it was tumbling past the sun at 196,000 miles per hour.
Respond exactly to the object's changing orientation relative to the sun. These variations create a pattern that matches theoretical models for advanced light sail technology, the kind that can maintain stability regardless of orientation. Kaku's team found these micro-adjustments would require what he calls responsive surface geometry.
Oumuamua may be a fully operational probe sent intentionally to Earth vicinity by an alien civilization.
Essentially a surface that can adapt its reflective properties dynamically. Technology we've only begun to imagine in theoretical papers, not something that occurs naturally in space. The precision needed to achieve such trajectory stability while tumbling is beyond our current engineering capabilities. It's as if Oumuamua knew exactly how to interact with solar radiation.
Oumuamua, as it stands, is a phenomenal discovery and a really important object
to maintain its course. This raises a provocative question. Could Oumuamua be equipped with an advanced passive sail system designed to harness radiation pressure from stars? A silent, efficient propulsion technology that allows it to drift purposefully through interstellar space? If you're finding this as mind-blowing as we did, make sure to hit subscribe and the notification.
Oumuamua did not behave like an ordinary asteroid or give off gas like a comet.
Bell. We'll be bringing you more revelations about Oumuamua and other cosmic mysteries that mainstream science isn't talking about. But what happens next is even crazier than the propulsion anomalies. The origin of Oumuamua raises even more troubling questions. Using the European Space Agency's Gaia spacecraft data, astronomers have now precisely traced.
Oumuamua, by contrast, is the first observed object to come from outside of our solar system.
Oumuamua's trajectory back to its origin point. The Gaia mission has mapped over 1.8 billion stars with unprecedented precision, creating the most detailed three-dimensional map of our galaxy ever assembled. When scientists ran Oumuamua's trajectory backward through this stellar database, they made a discovery that defies conventional astrophysics. The object came from what astronomers...
object that he claims is either a junk debris or maybe it's a tourist scout or a spy drone.
It's much more reflective, rather, right?
Astronomers call the local standard of rest, but specifically from a particular region within it that's eerily devoid of the cosmic mechanisms needed to naturally eject objects at interstellar speeds. Here's why this is significant. Natural interstellar objects should originate from regions with strong gravitational dynamics. Binary star systems where two stars orbit each other can eject comets and
terrestrial human technology that is capable of what these objects have been seen doing.
Through complex gravitational interactions, massive stars can blast material outward through powerful stellar winds or supernova explosions. But Oumuamua's origin point has none of these ejection mechanisms. The new analysis confirms there are no binary star systems within 10 light-years of its origin point, no massive stars that could generate the necessary ejection velocity, no recent supernova events in that region, no star clusters with the gravitational dynamics needed to accelerate an object to interstellar speeds. This region is essentially a gravitational dead zone, a quiet neighborhood of space where objects should remain relatively undisturbed. There's simply no known natural mechanism that could have accelerated Oumuamua to the velocity needed to escape its home system and travel to ours. The ESA data is clear. This object came from the one place in our stellar neighborhood where it shouldn't have been able to leave on its own. It's as if Oumuamua was placed in this quiet region deliberately where its launch would attract minimal attention, waiting to drift through space until it reached our solar system. This adds significant weight to the theory that Oumuamua may have been launched deliberately. If you wanted to send an object through interstellar space without drawing attention to its point of origin, you would choose exactly this kind of stellar dead zone, a region where no natural ejection events would be expected. What do you think? Let us know in the comments below what you believe Oumuamua's true origin might be, And if you want to stay updated on this developing story, make sure to subscribe and hit the notification bell. AI reveals a pattern spin for 515, but the most unsettling discovery might be what we've learned about Oumuamua's rotation. What initially appeared to be random tumbling now reveals something far more calculated. In March 2025, researchers applied advanced deep learning algorithms to reanalyze the complete data set of Oumuamua's brightness variations. These variations, which change by a factor of 10 every 7.3 hours, were previously thought to indicate a chaotic tumbling motion typical for an irregularly shaped object drifting through space. The new AI analysis tells a different story. The deep learning system, designed to detect patterns too subtle for human observation, identified something remarkable. Oumuamua's rotation follows a complex but predictable mathematical sequence. This isn't random tumbling you'd expect from a natural object. Instead, it's a deliberately programmed pattern. Here's what the data specifically shows. First, the primary rotation cycle maintains a precise 7.3-hour period with variance of less than 0.002%, a level of consistency virtually impossible for a natural object traveling through space for thousands of years. Second, superimposed on this main rotation are micro-rotational adjustments that occur at regular 43.8-minute intervals. These smaller rotational shifts appear to systematically expose different surface areas to solar radiation. Third, and most telling, is that these rotational patterns create a scanning motion as if methodically surveying its surroundings as it passed through our solar system. When engineers analyze this rotation pattern, they recognize something familiar. It matches theoretical models for optimal energy collection in spacecraft design. Controlled rotation is often used to ensure even temperature distribution and maximum solar panel exposure. Oumuamua's rotation cycle would be ideal for an object designed to harvest stellar energy as it travels between star systems. This pattern spin would serve multiple functions for an artificial probe: energy harvesting from stellar radiation, systematic scanning of surrounding space, signal broadcasting in multiple directions, thermal regulation to prevent overheating on the sun-facing side. If confirmed, this opens up the possibility that Oumuamua wasn't just drifting, it was actively calibrating itself as it passed through our solar system, potentially harvesting energy, relaying data, or even scanning Earth and our neighboring planets. What makes this finding particularly significant is that the pattern wasn't obvious in initial observations. It only became apparent through sophisticated AI analysis of the complete data set, suggesting an intention to appear random while following a precise program. The implications are clear. If Oumuamua is following a programmed rotation cycle, it's not just a piece of interstellar debris. It's something that was designed with purpose. The thermal signature paradox. Perhaps the most perplexing aspect of Oumuamua, and what has physicists genuinely concerned, is what's been called the thermal signature paradox. Every object in space has a thermal signature. When the Spitzer Space Telescope aimed its sensitive infrared detectors at Oumuamua in November 2017, scientists expected to see a clear heat signature. After all, the object had just passed within 0.25 astronomical units of our Sun, closer than Mercury's orbit. At this distance, surface temperatures should have reached well over 500 degrees Fahrenheit, 260 degrees Celsius. But Spitzer detected nothing, no heat signature whatsoever. The 2025 reanalysis of this data, using enhanced thermal mapping algorithms, has confirmed something that defies the laws of thermodynamics as we understand them. Oumuamua absorbed solar radiation but somehow didn't re-emit it as infrared energy. This is physically impossible for any normal matter. Even the darkest, most non-reflective asteroids and dead comets show thermal emissions when they pass near the Sun. It's an unavoidable consequence of absorbing solar energy. For context, when Comet Boris, another interstellar visitor, passed through our solar system in 2019, its infrared signature was clearly detectable, exactly as physics would predict. But Oumuamua, despite being closer to the Sun, showed nothing. The implications of this thermal invisibility are profound. There are only three possible explanations, each more unsettling than the last. First, Oumuamua could be composed of an unknown material with extraordinary thermal insulation properties, something far beyond any natural substance we've ever encountered in space. Second, It might incorporate what physicists call metamaterials, engineered structures designed to manipulate electromagnetic radiation in ways ordinary materials cannot. NASA has been researching similar technologies for spacecraft shielding, but nothing close to what would be required to produce the effect observed with Oumuamua. Third, and most disturbing, is the possibility of intentional thermal cloaking technology specifically designed to hide the object's heat signature from detection. This last possibility aligns disturbingly well with NASA's own research into stealth technologies for future space probes. Developing advanced aerogels and reflective metamaterials that could theoretically reduce a spacecraft's thermal footprint. However, NASA's most advanced concepts would only reduce thermal signatures, not eliminate them completely as we've observed with Oumuamua. The chilling implication: what if Oumuamua was specifically designed to avoid detection? What if its thermal cloaking technology worked so well that we only noticed it by chance when it passed unusually close to Earth? And the most troubling question: if one such object has come through our solar system, how many others might have passed by undetected? This thermal paradox isn't just strange, it represents a deliberate violation of the physical principles that govern all natural objects in space, and that's precisely what has Michio Kaku and other leading physicists deeply concerned. Intelligence in disguise, the debris theory. The new data has pushed scientists like Kaku and Harvard's Avi Loeb toward a startling hypothesis, one that fundamentally changes how we think about first contact with extraterrestrial intelligence. In April 2025, Kaku published an analysis examining Oumuamua not as an active probe but as technological debris, what he and Loeb have termed a technological relic. This theory suggests we're not looking at a fully functional alien spacecraft, but rather at the remnant of one. The evidence supporting this hypothesis is compelling. First, Oumuamua's unusual shape, roughly 400 meters long and only 40 meters wide, resembles nothing we've seen in natural space objects but bears striking similarities to components of human spacecraft design. Specifically, its proportions match those of a communications array or a damaged light sail. Second, its peculiar tumbling motion indicates it's no longer under active control. The AI-detected pattern suggests a system that was once regulated but has since degraded to a semi-predictable state, like a damaged gyroscopic system still following parts of its original programming. Third, its lack of emissions or transmissions points to non-functionality. If it were an active probe, we might expect some form of data transmission. Instead, it's silent yet still exhibiting non-natural characteristics. This debris theory connects directly to what astronomers call the litter hypothesis, a proposed solution to the Fermi paradox. This hypothesis suggests that the first evidence of extraterrestrial intelligence we detect might not be an active signal or visitation but their technological garbage, the remains of their exploration efforts scattered through interstellar space. It's a sobering thought. We've always imagined first contact would come with a clear signal or deliberate spacecraft. But what if it comes in the form of technological waste, parts of ancient probes drifting between stars for millions of years? But there's an even more unsettling possibility that Kaku has raised. What if Oumuamua isn't space junk at all but a sensor that has already completed its primary mission? Consider this scenario. An advanced civilization sends thousands of small efficient probes throughout the galaxy. These probes are designed to observe star systems, collect data, and then go dormant, appearing as inert objects while they drift to their next destination. The trajectory analysis shows that Oumuamua's path took it through the most information-rich part of our solar system, close enough to scan Earth and the inner planets, but not so close as to risk detection or capture. Its acceleration away from the Sun could have been the final phase of its mission here. If Oumuamua was indeed a surveillance probe, then it's already transmitted everything it learned about us back to its point of origin, and we never even realized we were being studied until the object was already leaving our solar system. This is precisely why Kaku finds the new data so concerning. Oumuamua might represent not just the existence of extraterrestrial technology but the possibility that we've already been observed, catalogued, and analyzed by an intelligence we know nothing about. The passive probe theory. The implications of the new 2025 data have led Michio Kaku to propose what may be the most concerning theory yet. Oumuamua wasn't debris or a derelict. It was a fully functional passive surveillance probe designed specifically to observe without being detected. Kaku's passive probe theory is built on several key data points from the latest analysis. First, Oumuamua's trajectory through our solar system was remarkably efficient for gathering intelligence. It followed what military strategists would call an optimal reconnaissance path, coming close enough to observe Earth and the inner planets in detail but maintaining sufficient distance to avoid easy detection or interception. The trajectory analysis shows it passed through regions that would provide maximum information about our technological civilization with minimal exposure. Second, its unusual physical properties now appear less like random anomalies and more like deliberate design choices. The thermal invisibility, the precise acceleration without visible propulsion, and the carefully maintained tumbling pattern all point to technologies optimized for stealth observation. Third, the object maintained a perfect listening position during its closest approach to Earth. The 2025 reanalysis of its position data shows that Oumuamua was ideally situated to receive our global communications, television, radio, and internet broadcasts, for approximately 72 hours as it passed through our system. This passive surveillance approach aligns with logical protocols for interstellar reconnaissance. Active probes that transmit signals or approach planets directly would risk detection and potentially hostile responses. A passive probe that merely observes and records would be far safer and more efficient. What might such a probe be designed to detect? The spectrographic analysis capabilities necessary would allow it to analyze atmospheric composition to detect biosignatures and industrial pollutants, measure electromagnetic emissions to assess our technological development level, monitor communications to gather data on our languages, culture, and societal organization, catalog resource distribution to evaluate our planet's strategic value. Kaku has emphasized why this scenario is particularly concerning. We should be cautious. Not all encounters in history end peacefully. He points to historical precedents where initial reconnaissance was followed by more direct contact, not always with benevolent intentions. If Oumuamua was indeed a surveillance probe, then everything it observed about us, our technology, our military capabilities, our resources, and our internal conflicts, has already been transmitted back to its point of origin. We have been thoroughly evaluated by an intelligence we know nothing about, using technology far beyond our current capabilities. This asymmetry of information, they know about us but we know virtually nothing about them, places humanity in a potentially vulnerable position. And the most troubling aspect, we only detected Oumuamua by chance. How many other such probes might have passed through our solar system completely unnoticed? There will be more. The most alarming conclusion from the 2025 analysis isn't about Oumuamua itself, it's about what its detection implies for our future. Based on the statistical analysis of our limited observational capabilities, astronomers now estimate that approximately one Oumuamua-like object passes through our inner solar system every year. This isn't speculation, it's a mathematical certainty derived from detection probabilities and observational constraints. The sobering reality is that we've only detected one such object because our current detection systems are woefully inadequate. Most interstellar visitors likely pass through our system completely unnoticed. The data shows exactly why we missed them. Most interstellar objects are only detectable for 5 to 10 days during their closest approach. Our current survey telescopes cover only about 15% of the sky at the required depth. Objects with thermal invisibility like Oumuamua are particularly difficult to detect. Many approach from angles that place them in the sun's glare from our perspective. The Vera Rubin Observatory, scheduled to begin full operations in late 2025, will dramatically improve our detection capabilities. Its 8.4-meter primary mirror and 3,200-megapixel camera will survey the entire visible sky every 3 nights, increasing our ability to spot incoming interstellar objects weeks or even months before they reach the inner solar system. This advanced detection capability is critical because it opens the possibility of interception. Project Lyra, a mission concept developed by the Initiative for Interstellar Studies, has proposed using a Jupiter gravity assist followed by a solar sail maneuver to reach speeds of up to 70 km per second, fast enough to catch up with objects like Oumuamua. The physics are challenging but possible. A spacecraft launched within 6 months of detection could intercept it. It requires approximately 5 to 6 times the delta V of a Mars mission. It would need nuclear, thermal, or advanced solar electric propulsion. Such a mission could reach the target within 2 to 3 years of launch. But there's a more ominous aspect to these future encounters. If Oumuamua was indeed an artificial probe, then what we detected was merely a reconnaissance mission. History teaches us that reconnaissance is often followed by more direct forms of contact. The statistical model suggests something unsettling. If these objects are artificial in nature, their frequency implies a systematic survey of our region of the galaxy. It's as if something or someone is methodically mapping nearby star systems. Kaku and other physicists warned that we should prepare for the possibility that next time the visitor might not just pass by, it might slow down, it might approach Earth directly, it might establish contact, and given what we've learned about Oumuamua's technological capabilities, we would be virtually powerless to stop it if its intentions weren't peaceful. The open question, as we reflect on the extraordinary data that has emerged in 2025, we're left with a profound mystery that challenges our understanding of our place in the cosmos. The evidence we've examined isn't based on speculation or wishful thinking, it's drawn from rigorous scientific analysis conducted by leading institutions using our most advanced observational and computational tools. Oumuamua accelerated away from our Sun without any visible propulsion mechanism. The 2025 data confirms this acceleration wasn't random but followed a precise mathematical pattern that counterbalanced its tumbling rotation, a feat impossible for natural objects. The acceleration curve exactly matches what we would expect from an advanced light sail technology, but one far more sophisticated than anything humans have designed. It originated from a region of space where no natural object should have gained interstellar velocity. The ESA Gaia mission data conclusively shows its trajectory traces back to a stellar dead zone with no binary systems, no massive stars, and no supernova events that could naturally eject material at such speeds. This origin point makes no sense for a random interstellar wanderer but would be an ideal launch position for an object designed to avoid drawing attention to its point of origin. Despite passing within 0.25 astronomical units of our Sun, it produced no detectable thermal signature whatsoever. The enhanced thermal mapping algorithms applied to the Spitzer data in 2025 confirm this object somehow absorbed solar radiation without remitting it as infrared energy, a property that defies the basic laws of thermodynamics for any natural material. This thermal invisibility matches theoretical models for advanced stealth technology. Its rotation wasn't the chaotic tumbling expected of an irregular space object but followed a complex pattern that the AI analysis reveals was optimized for systematic scanning and energy collection. The precise 7.3-hour rotation period maintained a variance of less than 0.002%, a level of stability impossible for a natural object traveling through space for millennia. And perhaps most fundamentally, its physical properties suggest it may not be a rock or comet at all, but something designed and constructed. Its extreme aspect ratio, reflective properties, and anomalous acceleration all point to artificial origin, what Kaku and Globe describe as a technological signature we cannot ignore. Oumuamua is gone now, having left our solar system on its hyperbolic trajectory, never to return. We had only a brief window to study it, and we were woefully unprepared for what we found. But the questions it leaves behind are profound. If it was watching us, we'll never know what information it gathered. We'll never know what conclusions it drew about our civilization, our technology, or our potential as a threat or ally. And most unsettling of all, we'll never know who else it told about us. As Michio Kaku warns, we should prepare ourselves because Oumuamua may have been the first messenger from beyond our solar system, but if the statistical models are correct, it certainly won't be the last. For those of you who want a quick refresher on the basic facts about Oumuamua, here's what we know for certain. Oumuamua was first discovered on October 19, 2017, by the Pan-STARRS telescope in Hawaii. The name Oumuamua comes from Hawaiian meaning a messenger from afar arriving first, an eerily appropriate designation given what we've learned. The object is approximately 400 meters long and about 40 meters wide, giving it that distinctive cigar or pancake-like shape that's roughly 10 times longer than it is wide. This extreme aspect ratio is unlike any natural asteroid or comet ever observed in our solar system. It rotates completely once every 7.3 hours, causing its brightness to vary by a factor of 10 during each rotation cycle. This dramatic brightness variation is what first alerted astronomers to its unusual shape. There are competing natural hypotheses attempting to explain Oumuamua. The leading natural explanation suggests it might be a nitrogen or hydrogen iceberg ejected from a distant planetary system. A 2023 study proposed that cosmic rays could create trapped hydrogen within water ice, which might provide the thrust to explain its acceleration. However, even NASA's official assessment notes it is completely inert without the faintest hint of dust around it, a description that contradicts how natural comets typically behave when approaching the Sun. While these natural explanations remain possibilities, the new data from 2025 that we've explored today raises profound questions about whether they can fully account for all of Oumuamua's anomalous properties. Whatever the truth may be, Oumuamua has forever changed how we view our place in the cosmos, and it may be just the beginning of a new chapter in humanity's greatest mystery. Are we alone in the universe? If you found this discovery fascinating, you won't want to miss what's coming next. The universe is filled with mysteries that challenge everything we think we know. Subscribe and turn on notifications. You'll be the first to know when the next cosmic enigma appears. Our team is already working on breaking down more of Michio Kaku's latest revelations that mainstream science isn't covering.